Now example number 3. The mass of an imaginary planet is 4 times that of the Earth and its radius is double the radius of the Earth. The escape velocity of a body from the Earth is 11.2 into 10 raised to 3 meter per second. Find the escape velocity of a body from the planet. For this, given things are, let the mass of the Earth is m1 and mass of an imaginary planet be m2 and their respective radii are r1 and r2. Therefore, m2 is equal to 4m1 because the mass of the planet is 4 times that of the Earth and this radius is double the radius of the Earth. Therefore, r2 is equal to 2r1. Now, escape velocity from the Earth is equal to v1 escape and escape velocity from the planet is equal to v2 escape. So, therefore, v1 escape is given 11.2 into 10 raised to 3 meter per second. Therefore, v2 escape we have to calculate, that is question mark. We know escape velocity is equal to v escape is equal to square root of 2 gm upon r. According to this, we will write v1 escape is equal to square root of 2 gm1 upon r1 and for escape velocity, that is v2 escape is equal to square root of 2 gm2 upon r2. Therefore, v2 escape upon v1 escape we have to calculate, that is equal to these values we will put, that is square root of 2g m2 upon r2 upon square root of 2g m1 upon r1. Now here this 2g will get cancelled. So what is remaining, children, here? Square root of m2 upon m1 into r1 upon r2. Okay, so that is equal to, here instead of m2 we will write m1. Instead of m2 we will write here 4m1 and instead of this r2 we will write here 2r1 because we know m2 is equal to 4m1 and r2 is equal to 2r1. So here m1 will get cancelled, r1 will also get cancelled. So in the square root we will get 4 upon 2, that is equal to square root of 2, that is 4 ones, 2 ones are 2, 2 twos are 4. So it will be square root of 2. So therefore v2 escape upon v1 escape is equal to square root of 2 upon 1. Now here we will do cross multiplication. So we get v2 escape into 1 is equal to square root of 2 into v1 escape. Therefore v2 escape is equal to square root of 2 into 11.2 into 10 raised to 3. That v1 escape value I put here. But we know here, children, square root of 2 value is 1.414. Okay, into 11.2 into 10 raised to 3. So after multiplication we will get v2 escape is equal to 15.84 into 10 raised to 3 meter per second. Now here this 10 raised to 3 means what? This is in meter. We have to convert this into kilometer. We know now here 1 kilometer is equal to 1000 meter. So 1000 meter means 10 raised to 3 meter. So here we are getting v2 escape is equal to 15.84 kilometer per second. Therefore, the escape velocity of a body from the planet is equal to 15.84 kilometer per second. Now, example number 4. A body is released from the top of a tower of height 50 meter. Find the velocity with which the body hits the ground. Therefore, g is equal to 9.8 meter per second square. This is given thing. So, we will write first of all, in case of this example, given things, given g is equal to 9.8 meter per second square. h is the height, that is here distance only, that is 50 meter, and initial velocity of the object is 0 meter per second. Now here we will solve with the help of Newton's law, that is according to Newton's third equation of motion, v square is equal to u square plus 2gs. Now v square is equal to 0 square plus 2gs. Therefore v square is equal to 2 into gs. So we will put here respective values, that is 2 into 9.8 into 50, that is this is distance. So v square is equal to 9.8 into 100. So v square is equal to 980. Now taking square root on both sides, we will get here v value, that is its velocity value. So how to take their square root? We know 30 square is what? 900. 31 square is 961. 32 square is 1024. So obviously our 980 is in between this 31 and 32. So I took here tentative squares, that is 31.2 square, I got 973.4. Then afterwards I took 31.3 square, that is 976 into 0.69. But here my value is 980, that is velocity. 980 is there. So again I did 31.4 square, that is 985.96. So that is too much bigger than this. 980. So therefore 31.31 square. So that is getting 980.31. Therefore I got value, that is v square, that is velocity of the body. V square is equal to 31.31 square. Therefore velocity of the body v is equal to 31.31 meter per second. Therefore the velocity with which the body hits the ground is equal to 31.31 meter per second. Example number 5. The radius of a planet A is half the radius of planet B. If the mass of A is ma, what must be the mass of B so that the value of G on B is half that of its value on A? Now first of all we will write given things. That is radius of the planet A is equal to RB upon 2. Means this radius of the planet A is half of the radius of the planet B. So I wrote here RB upon 2. Now here we have to calculate mass of the planet B. So MB is equal to question mark. Now here this value of G on B is half of its value on A. So therefore GB is equal to half GA. Therefore this gravitational acceleration or acceleration due to gravity is equal to gm upon r square. So we will write this formula with respect to planet A and planet B, that is Ga is equal to G into ma upon ra square and Gb is equal to G into mb upon r b square or r square b. Therefore this will divide to each other, that is Gb upon Ga is equal to Gmb upon r square b upon Gma upon r square a. Now here Gb will be half Ga and here Ga as it is equal to this Gg will get cancelled, that is universal gravitational constant will get cancelled. So here what is remaining right hand side? Mb upon Ma into r square a upon r square b. This is to denominator to denominator. So when it will come up, it will be to numerator, that is r square a upon r square b. Now here Ga will cancel. So what is remaining right hand side? That is 1 upon 2 is equal to Mb upon Ma into here r square a is Ra value we know, that is Rb upon 2 bracket square upon r square upon r square b. Therefore 1 upon 2 is equal to Mb upon Ma into r square b upon 4 into 1 upon r square b. Here this r square b will get cancelled. Therefore 1 upon 2 is equal to Mb upon Ma into 1 upon 4. Therefore 1 upon 2 is equal to mb upon 4 ma. Therefore, 4 ma means here we will do cross multiplication. 4 ma into 1 is equal to 2 into mb. Therefore, 4 into ma upon 2 is equal to mb. So, here we can divide this 4 by 2, that is 2 ones are 2, 2 twos are 4. So, what is remaining here, children? 2 ma is equal to mb, means mb is equal to 2 into ma. Therefore, mass of B must be twice the mass of A, so that the value of G on B is half that of its value on G, value on A.